Hi, and welcome to our poster. Prior work shows that decision-making extends beyond the mind and can be indexed by motion, such that observers can determine whether a decision is freely made or forced, or determine what decision is being made before it's even completed. This, coupled with prior work demonstrating different behavior under different goals, led us to the use of games as context for a study. The structure afforded from games creates expected structure for cognition and behavior, allowing for high realism and experimental control. The larger goal of this investigation is to explore different aspects of social cognition, such as gaze and motion, across contexts. With the change in research due to COVID-19, we pivoted to designing an online version of our study. This prompted our two questions. Namely, is it possible to create an online dyadic task with real-time sharing of data accessible by personal devices? If we cleared the hurdle of implementation, could we create criteria to check for participant performance quality? The task was programmed in LabVance and is a simple two-player card game. The goal of the game is to win points by collecting cards that match the personal goal, which could be a color, shape, or number of items. For example, this card has two red circles, giving points to anyone collecting red circles or two items. The building block of the game is a turn, which contains two discrete decisions or phases. In the draw phase, player 1 draws two cards, views them, and decides which to present to player 2 face up and which to present face down. Next is the choose phase, where player 2 decides whether to select the face up card or the face down card to add to their hand. The other card is added to the hand of player 1. Players alternate drawing and choosing from turn to turn, with 4 turns making up a round and 3 rounds making up a game. Participants played 4 games. We performed 2 manipulations. First was the overall dyad goal, with games alternating between players competing to win the most points or cooperating to earn a higher combined number of points. The second manipulation was the level of conflict, which changed from round to round. This was done by manipulating both participants' personal goals to be either in full conflict, partial conflict, or no conflict. For example, in partial conflict, player 1 could be collecting triangles, and player 2 could be collecting green. Is it feasible to test 2 people online with their own devices? Yes. By using the LabVance platform, we were able to test participants online from both Amazon MTurk and the Undergraduate Research Participation Pool. Can we create exclusion criteria to check participant performance quality? Yes. Here are 3 examples. First, we can use mouse trajectory data to detect improper gameplay. For proper gameplay, the draw player must view both cards once, resulting in at least 2 views or peaks for each draw phase. By plotting average number of peaks for all 36 participants, we can exclude those with less than 2 peaks on average, as they could not have been playing the game properly. Second, we can use response time to determine inattention. This plot shows the time between the start of the trial and the player's first interaction. We can exclude participants with average pre-interaction times greater than 3 standard deviations from the mean, as they weren't attentive. In addition, by visualizing mouse movements, we can visualize improvements in participant gameplay, as seen in the increase in movement efficiency between the left picture, showing a participant's first draw phase, and the picture on the right, showing the same participant's draw phase later in the game. Now that we've tested the feasibility and quality of the task, we've made 3 major changes to the game. First, we increased the number of turns to 8 to allow participants time to interpret the other player's movements and decisions. Second, as the most interesting decisions occurred under partial conflict, we are only using those trials. Third, we isolated the most compelling decisions to populate the new study and isolated the most basic decisions for the baseline. We will also be working to implement eye tracking and projection in the new version, as research shows gaze to be crucial in social communication. Thanks for stopping by.